Hello, this lesson is on solving systems in three variables. And so we'll start with this statement. The most famous method for solving systems is Gaussian elimination, which uses elimination to get a system of three variables in triangular form like this. So triangular form is when you have a system of three equations in three unknowns, x plus 2y plus z equals 7. So one equation has three unknowns. The second one just has two unknowns, y and z, for example, and the third one has one unknown. So this is the easiest type of system in three variables to solve because we can just use something like back substitution to solve for the equation that just has one variable. So if we solve for z, that's z 2z divided by 2, z equals 3. And then we can take that information and plug it into the second equation with two unknowns and get negative y plus 3z, which is now 3, is equal to 9. So negative y plus 9 equals 9. Negative y equals 0, so y equals 0. And then we can take those two and plug it into the first equation to find x. So x plus 2 times y, which is 0, plus z, which is 3, is equal to 7, gives you x plus 3 equals 7, so x is 4. And just like systems with two variables, with three variables, you want to make sure you put your solution as an ordered triple. So an ordered triple, just like an ordered pair, always has the same order, the x coordinate, the y coordinate, and then the z coordinate. So this solution would be 4, 0, 3. So make sure you don't forget that final step so I can check to make sure you know the ordered triple is x, y, z. All right, so you might want to pause and try example 2, or we can just keep going. So we're going to back substitute. We have an equation where we can solve for z. So we divide both sides by negative 2, we get z equals negative 1/2. Then we can go to the second equation and find out what y is by plugging in negative 1/2 for z. So that's y minus 2 equals 0, or y equals 2. And then we can go to the equation that has three unknowns to find out what x is. So that's 2x minus, y is negative 1/2, so it's minus a negative 1/2, plus 6. Oops, I put that in the wrong spot. So minus y is 2, plus 6 times z, which is negative 1/2, equals 5. So that gives me 2x minus 2 minus 3 equals 5. So that gives me 2x minus 5 is equal to 5. So that gives me 2x is equal to 10 and x is equal to 5. So the ordered triple here would be x is 5, comma, y is 2, comma, z is negative 1/2, parentheses. So that's your ordered triple there. Okay, so that's the easiest type of system in three variables to solve. All right, now we're going to get more difficult. I, again, think this is medium in difficulty, and most of the time we're going to use the elimination method, so you might want to review the elimination method if you need to. But the reason that I'm calling this medium is it's still hard for students, but it's not as much work because if you notice, this first equation has three unknowns. Second equation had three unknowns, but the third equation is missing the y already. Okay, so your general idea is you want to go from three equations with three unknowns to two equations with two unknowns to one equation with one unknown. That's what elimination will do for you. So if you have an equation that's already missing a variable, then you're already halfway done with the second step in the process. So I'm just going to circle that, and we're going to notice that the y is missing. So that means I'm going to use elimination to get rid of the y in the first two equations. So they're both 1y, so I'm just going to multiply this second equation by negative 1. Okay, so I'm going to multiply that second equation by negative 1. I'm going to rewrite 2x plus 1y minus 1z equals negative 8. That's equation 1. And then in equation 2, I'm going to multiply through by negative 1, which would be positive 1x minus 1y minus 1z equals negative 3. And you may want to check your work. All of these signs should change. Now I'm going to add. So I get 3x, and the y's are 0, minus 2z is equal to negative 11. All right, so what we are doing is we're going from 3 equations with 3 things we don't know down to now we have 2 equations with 2 things we don't know. And they're written side by side, but we can write them vertically just like normal. So we just have a problem that we did with a system of 2 unknowns. So I'm just going to rewrite the 2 equations right on top of each other. All right, we're going to use elimination again. So if I want to get rid of the z's, there's a 4 there. A negative 4 would eliminate that. So I'm going to multiply both sides by 2. And that's going to give me negative 2x plus 4z equals 18. And 6x minus 4z equals negative 22. So we got to make sure we multiply both sides by 2. So now I'm going to add, and I get 4x, and the z's cancel, equals negative 4. So see the idea? I started out with 3 equations with 3 unknowns. I went to 2 equations with 2 unknowns by eliminating a y. And then I went to 1 equation with 1 unknown, and I know how to solve it. So divide by 4 and get x is negative 1. Now you have to go back the way you came. So I now know x, so I want to go back to the equations that had an x and then one other unknown. So I'm just going to do that here because there's space right here. So that's 3 times negative 1 minus 2z equals negative 11, which is negative 3 minus 2z equals negative 11. So I add 3, and I get negative 2z equals negative 8. And divide by negative 2, and z equals 4. So now I have x is negative 1 and z is 4. So now I can go back to where there's a y and figure out what that is. I'll use the top equation. So 2x plus y, well, y is unknown. Let me start over. So 2x, we know it. I'm pointing right here at it. 2 times negative 1 plus y, we don't know that, minus z, we know z is 4, equals negative 8. So that's negative 2 plus y minus 4 equals negative 8. So that's negative 6 plus y equals negative 8. So that's y equals negative 2. So write it as an ordered triple, and we have negative 1, negative 2, 4. And just like before, you could check to make sure that that is correct by putting those values of x, y, and z in 3 times. It has to be checked for all 3 equations. Okay, now this next one is going to take probably a little bit longer because, remember, this was a good news. This system had one that was already missing a y. So all we had to do was get rid of the y here. But if you look at this example, there's nothing missing. All 3 of them have an x and y and z. So this is where it gets a little tricky. You have to make a decision. And so I would look at the x's and say, well, do I want to eliminate the x's? You're going to have to do it twice. And it's a good candidate because there's a 1 here. Or I could get rid of the y's, and that's a good candidate because there's a minus 1 here. Or I could get rid of the z's because there's already opposites here. So you just pick, it doesn't matter. And I am going to get rid of the z's. So what you want to do is you have to pick 2 of these 3 at a time. Okay? So I'm going to pick equation 1 and equation 3 because they're already opposites. And so I'm going to add. and get 5x plus 3y equals 3. So I got rid of the z's one time using equation 1 and equation 3. So I get this new equation. Okay, so now I have to go back and pick another pair of equations and get rid of z. You have to make sure you get rid of the same variable twice. So this time I'm going to pick equation 2 and 3. And just look at equation 2 and 3 and notice that if I multiply equation 3 by 3, I'll get opposites. Okay, so I'm going to copy down equation 2. It's already set up with the 3z, or negative 3z. So x plus 2y minus 3z equals negative 4. And I'm going to multiply equation 3 by 3. So 3 times equation 3. I'm just kind of writing this down so you hopefully won't get lost. So I've got to make sure I multiply this to all 4 terms. So that's 9x minus 3y plus 3z equals 3. Now I'm going to add, and 1x plus 9x is 10x. 2y minus 3y is minus y. The z's go away. Negative 4 plus 3 is negative 1. So see what I have now? It's a lot of work, but I have 2 equations, and they're both x and y. So now I'm going to start over, and for some reason it tends to help students to write them vertically so that really you've done this. We did this in the last lesson. So now I'm going to solve this system, and if I multiply the bottom equation by 3, the top equation is going to be 5x plus 3y equals 3, and the bottom will be 30x minus 3y equals negative 3. And that's going to give me 35x is equal to 0. So now I've started out with 3 equations with 3 unknowns. I went to 2 equations with 2 unknowns. And now I have 1 equation with 1 unknown. And I find out that x is equal to 0. So now I'm just going to go backwards. I'm going to plug 0 in for x and find out what y is. So negative y equals negative 1 means that y is 1. So now I know x and y. So now I'm going to go to a place where I can find z. It doesn't matter where you go. I'll go to the top. So that's 2 times x is 0, plus 4 times y, which is 1, minus z equals 2. Okay, so that is 2 times 0 is 0, and then 4 times 1 is 4, minus z equals 2, so negative z equals negative 2, so z equals negative 2. So the ordered triple is 0, and then 1, and then negative 2. Okay, so I hope that you could see all of that. But anyway, let's look at example 5. Okay, so now the backstory here is these used to be the hardest ones for me because I was overthinking it. Because this first equation has a y and a z, and the second equation has an x and a y, and the third equation has all 3. And I just used to be completely befuddled by that until I had to teach it. And see, I was trying to figure out which variable would be better to eliminate. But what you can do is just pick one. Pick one of these. Just pick one. It doesn't matter which one you pick. Just pick one. So I'm going to pick this one, and I'm going to circle it. And so once I pick that one, then it's just like this problem where once I pick it, what's missing? Well, the x is, right? So that means I'm going to take these 2 and make sure I get rid of the x. Okay, so this is 2x, this is negative 1x. So if I multiply this by 2, I'll get rid of my x's. So I'm going to copy that down. The second equation, 2x plus 3y plus 0z if you want to equals 2. And multiply this by 2, and you get negative 2x minus 4y plus 2z. time equals negative 2 because you multiply both sides by 2. And then that cancels and you have negative y plus 2z equals 0. So there's your second equation that is missing in x. So just pick one. We could have done the same thing if we picked x and y and got rid of the z's. All right, so then what you do is, remember, you line them up. So I have y minus 2z equals 0 and negative y plus 2z equals 0. And they're already opposites, and you might be seeing something weird happening. Y plus negative y is 0. Negative 2z plus 2z is 0. So you get 0 equals 0. So do you remember what you have to do there? Well, that's a true statement. So what that means is it doesn't matter what I put in for x, y, and z, as long as they follow a rule, right? So you have to remember how to find that rule. I'll tell you. So before you got in here, you used to be okay with just writing there are infinitely many solutions. But not any solutions, just that there's infinitely many, but they have to follow a rule. Okay? So when this happens in this class, what you're going to do with these three unknowns is you're going to do it this way. You're always going to let z equal z. And then you're going to get y in terms of z and x in terms of z. Okay? So you have to kind of look and see where there's a good place where you can get y in terms of z, and there it is. And what that means is you have to solve for y. So I'm going to solve for y here. So that's negative y plus 2z equals 0. So that's negative y equals negative 2z. So that's y equals 2z. And then after you have z equals z and y equals 2z, you're going to get x in terms of z. So you have to go find a place where there's an x. You can go here or here. I'm going to go here. So 2x plus 3y, but y is 2z, equals 2. So that's 2x plus 6z equals 2. So that's 2x equals 2 minus 6z. And then divide by 2, and you get x equals 2 divided by 2 is 1, and minus 6z divided by 2 is minus 3z. Okay, and then just like all the others, you're going to put this as an ordered triple. So the x is 1 minus 3z. The y coordinate is 2 times z. And the z coordinate is z. And so that tells me more than infinitely many solutions. There are infinite many, but they follow this pattern. So if z is 1, y is 2, and x is negative 2. If z is 2, y is 4, and x is negative 5. If z is 3, y is 6, and x is negative 8. And we could do this infinitely many, but they have a pattern the way they relate to each other. Okay, it's really important that you practice, so I would pause and try these and see if you can get it, and then come back and just watch me. Okay, so this first one, we aren't missing any variables. Okay, so this is the one that's going to take a lot of work. So you might decide to get rid of the x's. That's a good idea because there's a 1 there. You might decide to get rid of the y's because these are almost already opposites. You might decide to get rid of the z's because there's a 1 there. So I'm going to get rid of the y's. Okay, so I'm going to multiply equation 2 by negative 1. So I'm going to start with equation 1, x plus 2y minus 2z equals 1, and negative 2x minus 2y plus z equals negative 6. Here's a little tip. I felt my brain getting overloaded, so sometimes I'll just put my pencil down and then check the sign. So negative 2, positive z, negative 6. Okay. Now I'm going to add, and I get negative 1x minus 1z equals negative 5. Okay, so think about what we've done. We have 3 equations, 3 unknowns. We just got rid of the y, so we're going to have to do that again. I used equation 1 and -1 times equation 2. So I used 1 and 2. Now I have to use another pair. So I'm getting rid of the y's. So I'm going to use equation 1 and 3. You could use 2 and 3. Doesn't matter. But if I use 1 and 3, and I want to get rid of the y's, just look at 1 and 3. I need to multiply 1 by -2. So I'm going to multiply equation 1 by -2. And that's going to give me -2x minus 4y plus 4z equals -2. Now I'm feeling a little overwhelmed, and I'm a professional, so I'm going to stop and check. -2, -4, +4, -2. Okay. And then equation 3, can't use equation 2 again because I already used 1 and 2. I got to use 2 different. So 1 and 3, and I'm just going to copy equation 3 down because it's already 4y. So that's 3x plus 4y minus 3z equals 5. So that's 1x plus 1z equals 3. So here it is. I have gone from 3 equations to 2, and 3 unknowns to 2 equations with 2 unknowns, and I'll stack them on top of each other so that we can just get confident that we're really now just doing the same thing but with a system of 2 variables. And then look what's happened here. That's 0 and that's 0, so the left side is 0, but the right side is -2. So that's a false statement, which means that there are no values of x, y, and z that are going to make a true statement, so that's no solution. All right, now, example 7, we've got my old nemesis, the ones that, this has x and y, that has x and z, that has all 3. Remember my trick? Just pick one. So I'm going to pick that one. Okay, once I pick one, I circle it, then I'm like, oh, that's missing a z. So that means I'm going to need to get rid of the z's up here. So I'm going to multiply this top one by 2. So that's 2x plus 6y minus 4z equals 0. So I'm going to check that again. 2, 6 minus 4, 0. And then I'm going to copy equation 2 down. 2x plus 0y plus 4z equals 4. And that gives me 4x plus 6y is equal to 4. And I could divide by 4, but take a quick look at this equation. If I put that equation underneath it, multiply it by -1, it's really the same equation, and you get 0 equals 0. So do you remember what happens, what you do when you have that? Well, remember, that's infinitely many solutions, but we don't say that. We say z is z. And then we're going to get y in terms of z or x in terms of z. Okay? Doesn't matter what order you do it. So I'm going to go to this 2x plus 4z. I'm going to get x in terms of z first because it's already got the z. So 2x equals 4 minus 4z. Divide each term by 2, and you get x equals 2 minus 2z. So now I know z is z and x is 2 minus 2z, so I just have to get y in terms of z. So I'm just going to go to this bottom one, 4x, which is 2 times 2 minus 2z, plus 6y equals 4. So if I distribute, I get 8 minus 8z plus 6y equals 4. Remember, we're trying to solve for y, so I need to move these two over here. So we end up with 6y equals 4 minus 8 plus 8z, which is 6y equals -4 plus 8z. Divide each term by 6, and you get y equals -2/3 plus 4/3 z. So our ordered triple is 2 minus 2z, and then negative 2/3 plus 4/3 z, comma z. Okay, so you need to practice these. You will have to show your work possibly on one of these on the test. But turns out you can actually use the TI-36X Pro to solve these. And this is why we recommend the TI-36X Pro. So if you don't have this type of calculator, it might not do this. But it does it right here, right above the tangent button where it says Sys Solve. Okay, so if you hit second in the tangent button, it'll go to System Solver. And there are two types of systems. There's 2 by 2 linear equations. That means 2 equations with 2 unknowns. Or there's 3 by 3 linear systems. That's 3 equations with 3 unknowns. And I feel like one person programmed number 1 and a different person programmed number 2, and so the methods are different. So I'll show you both of them. So for any system, the first thing you want to do is you want to make sure that you put your systems, your equations, in standard form. So if you have a 2 by 2, you want to make sure it looks like that. And if you have a 3 by 3, you want to make sure it looks like that. So you want to make sure your variables are on the left and your constants on the right. Okay, so A is a system of 2 unknowns, and so the first equation is just fine, but the second equation I'm going to need to move the 5 over. Okay, so once we do that, then we can put this in the calculator, and the way it's going to look is you have a 2 by 2, so you're going to hit number 1, and it says blank x plus blank y equals 0. So you're going to put the coefficient of the x in, 3, and then hit enter, and then it hovers over that plus, because if you have a minus like we do, you're going to change that to a minus, so just hit the minus button, and then 1y, so hit enter, equals 7. So you put the first equation in, and the second equation is 4x minus 5y equals negative 18. And then when you hit solve, it'll tell you that x is 53 over 11 and y is 82 over 11. And so it solves it for you. Okay, if you have a 3 by 3, it's going to look different. So this is a system of 3 equations, 3 unknowns. So what we're going to do is hit second quit, and then we'll go back to System Solver. So second system, and choose 2 for 3 by 3. So see, now the person who programmed this is called an augmented matrix. So this piece right here with that line, that's a 3 by 3 matrix. But when you have a system, you have 3 unknowns, and then you have these constants. So you don't really need to know all that. All you need to do is just put in the coefficients and the constants. So for this one, this first equation has a coefficient of 1, hit enter, goes across, and then 4, hit enter, and then negative 2, so type that in and hit enter, and then the constant is negative 3, so hit enter. And then equation 2 has coefficients of 2, hit enter, negative 1, hit enter, 5, hit enter, and 12, hit enter. And then equation 3 has coefficients negative 3 and understood 1. Now, if the variable was missing, you would have to put in a 0, and then hit enter, and then negative 4, and then negative 3. And then you hit solve, and it gives you that x is negative 1303, and see the down and up arrows right here? So I'm going to write that down. X is negative 13 over 3, and y is 8 over 3, and z, you want to write it as an ordered triple, is 14 over 3. Okay, so try this one. I'll pause and see how you do. Or you can just watch me. So you can hit quit, and go back. Number 2. And they're already in standard form. So 1 and 2 and negative 1 and 9. That's equation 1. Now equation 2, you're missing a y term. It's really important that you put that placeholder in. You have to have 0y, negative 1, negative 2. And then 3 and 5 and 2 and 22. And solve that. And you get negative 1, 5, and 0. Okay, last thing, I have a surprise for you. So remember this one? This calculator will even find these unknowns. So if we put this one in, so let's do solve again this time. And we put 1 and 3 and negative 2 and 0 in, and 2 and 0 and 4 and 4. And then x is 4, and then 6 is y. And then there's no z term, so 0, and then 4. And you hit solve. It'll even solve these infinite many solutions. So you get x is 2 minus 2z, which is what we got. And then you go down and you get, I made a mistake because that's getting a different answer here. So negative 2/3 plus 4, 3z, and then z. So let me see what I did here. Okay, so I found my error right here. So your calculator can help you find errors right here. I was contemplating how I was going to show my work, and I did it in my head. So the 4 gets copied down, minus 8 plus 8z. So 4 minus 8 is negative 4 there. And so negative 4/6 reduces in negative 2/3. Calculator, help me out there. All right, so that's solving systems with 3 unknowns and also how to use the calculator.